Hello everyone, in this video we are going to assemble a 4-wire 3-phase system and observe the effect of load imbalance on the neutral wire on the return neutral cable to the source. Our circuit will look like this. So here I will have there are 3 distinct phases involved here, and I have successfully established the necessary connection. Here, I will have a resistor. Then I will have another resistor and then another resistor. And this connection, and I'm going to place an ammeter right here. And then we will carefully examine and analyze the electrical current that will flow through the ammeter connected in the circuit when these resistances here are unbalanced. So let's go. I'm going to get an ammeter. I'll put it right here. And now I'll make the connections. I'm going to get a blue cable. I'm going to make the connection back here. I am going to head around the side, and I will take care of it right over here. All set, my connection is done, the ammeter is in series. All 3 resistors are at 500 ohms. I'm going to apply 100 volts. So my current here in the resistors will be 100 divided by 500, 1 over 5, which is 0.2 amperes. So I'm going to turn it on here. I'm going to apply 100 volts here. (102). I am going to match all of the phases now. 102, 102, 102, 102, and then everyone else as well. Take a look at the screen here. I'm showing this phasorially, represented in a phasorial diagram. I have here I'm going to completely switch off the voltage displays. So I'll leave only the currents visible and significantly increase the current scale for better visibility. So here I have my currents. The current reading is exactly 0.4 amperes. Yes, it is 0.4. These specific amperes represent my total applied currents right here in this setup. There are exactly 0.4 amperes flowing through the circuit at this moment. That's right, folks. My setting is for 250. It's 100 over 250, so it really is 0.4. I had said 500, but it's 250. And now what am I going to do? Well, I'm going to unbalance this system so we can start to see a neutral current. So I'm going to take this and make it unbalanced. Look, I start to have neutral current passing through the ammeter. So at this specific point in the process, I have a much lower resistance reading. That is to say, right here on the electrical connection for phase A, I have a lower resistance. So as you can see here, I have a measurement of 250 ohms. Here I have another 250. And finally, right over here, I have a reading of 120. That's right, let's round it to 120. So what does that mean? I'm going to have a current flowing through here. I'm going to have a current flowing through here. I'm going to have a current flowing through here. These two currents will be smaller than this first one. So this difference will, here in the sum, at this point, result in a current difference. And this current will flow over here, this difference in current. If we look at it here phasorially, here's our unbalanced circuit. 0.8 in phase A, with approximately 0.4 in B and approximately 0.4 in C, because phase B changed a bit, and approximately 0.4 in... So IBC is more or less similar, but IA is approximately double, and that's the difference that will flow here through the neutral. When I set this here and approach 250, my neutral current will tend to 0. And if I unbalance it here again, it tends to increase. Same thing for the others, same thing for the other phases. The imbalance of the phases will result in a current, a neutral current, which is a zero sequence current. It will result in a neutral current. So folks, that's what I wanted to show you. We learned how to measure the neutral current and understand where it goes when we have an unbalanced system, where the difference in current goes. It goes to the neutral. That's it, folks.